So we've talked about container as infrastructure. We've talked about container management as infrastructure. And we've talked about the fact that containers, being a valuable entity in the development world, are something that people are going to have to implement one way or another, either by providing access to a container management service as a service, so providing access to a Kubernetes or a Mesosphere DCOS, or providing the ability to deploy those as entity services for individual customers. So you can deploy your own Kubernetes, your own Docker Swarm, your own CoreOS, or what have you. So these are all options for managing and manipulating OpenStack or using OpenStack to actually support containers. And then of course there's the inverse, which is using containers as a way of managing your OpenStack service. And there's a lot more work that has to happen there. But really that's what I wanted to talk to you about now, was the things that are still not quite well defined. There's still some gaps in what the best architecture is, how we actually implement this most effectively. And it's not that there aren't implementations out there, but there are still some areas that you have to really be aware of and have to think through. For example, the networking environment. If I'm going to run containers on top of OpenStack, one of the problems I run into is that OpenStack often has already been built up on top of a networking topology that makes an assumption that there are tunnels that get created automatically by the Neutron driver for creating the networking environment on a tenant-by-tenant basis. Now that's fine and actually is usually pretty performant in most environments when you have a tenant talking to a tunnel on top of the bare hardware. Right, that's managed by OpenStack. When I then on top of that layer something like a CoreOS with the Flannel networking service, I suddenly have yet another tunnel on top of a tunnel. So I've double encapsulated my packets. And one of the problems we find is that that actually creates performance issues in some of the throughput limited applications in these environments. So it's really something to be aware of. There are models where you go with, for example, a static routed environment. So that's one approach, is to statically route everything. But those don't tailor well to container management as a service. So giving people the ability to deploy their own Kubernetes. If you deploy one Kubernetes environment or any of the others, for example, environment across your cloud service and provide that as an end unit for customers, then you can potentially integrate that a little bit more effectively into the overall network management paradigm and avoid the double encapsulation problem. There are other technologies like Calico or Romana that take a different approach to networking and actually can integrate fairly well. Actually, the Contrail tools can do this as well. Actually, I think most folks that have actually implemented drivers that support something like the Kubernetes CNI or the container networking interface model, so Calico, Romana, Cisco ACI, Contrail, etc. All of these technologies that actually support that interface can potentially have one networking service that talks to both containers and the infrastructure, virtual machine-based infrastructure services. But that's a limitation that you have to be aware of, and you have to architect around how is this actually going to work in your environment. Another one is storage. We have the same sort of multi-overlapping storage environments. If I'm going to provide local storage within the infrastructure as a service, I'm often talking directly to a set of storage arrays or particular storage arrays. If I don't have a device driver from the third party that my Kubernetes environment can actually talk to or my Docker environment can talk directly to, I potentially have to mount a container or mount a storage unit underneath a container and then map that storage unit to the container through the infrastructure service. And those integrations aren't really there yet. So really something to be aware of, especially if you assume that you're going to have access to maybe some high performance solid state disk and some local ephemeral class disk storage for your systems. Being able to do that mapping is not quite as automatable as many people I think expect or are assuming is available in infrastructure services today. So network, storage. On the compute side, I think we're actually much better off. I think the container model, because of its sort of compute heritage, ties very well into whether you're running on top of virtual machines or talking directly to the actual physical hardware underneath and being managed directly. In either case, you usually get full system performance from the compute environment as opposed to some of the interactions that might happen depending on the network or storage services that you actually choose. So in the bare components, the pieces integrate fairly well together. One of the other areas where I think there's still a gap in sort of best practice is if you do decide to run a container management solution as a service for your end users. So picking the Murano versus Magnum versus your own heat templates of your own devising, those services are not quite as well defined and as well pulled together yet as some of the other services that people expect and have seen from OpenStack. I mean, OpenStack has now multiple years, 5, 6 years plus of permutations and sort of getting better over time. I think it's there for many use cases in the infrastructure as a service, virtual machine enabled use case. I would even say that the physical server as a service use case is actually really well along as well, and is basically ready for prime time too. The container integration, I think there's still more work to be done. Unless you say, well, I'm just going to use infrastructure, and as an operator, I'm going to deploy that environment as a consistent single point of entry, effectively, on a per OpenStack environment solution for my end users. So I'm going to deploy Kubernetes. I'll tell them how to actually talk to the Kubernetes APIs, and they'll just get to use that one large, massive shared resource. So in that sort of a model, I think that the system is ready for that today. In the per tenant OpenStack deploying container service or container management for your end users, there's still some gaps there. So overall, we see OpenStack being able to run in containers, work in progress, but it's really making huge headway, and the Kolla project, I think, is the leading project in that space. There are other folks that are looking at enabling better container management, so basically mapping like the Kubernetes model for managing OpenStack services against that. So I think that's coming along quite well. Again, not necessarily the sort of thing you're quite ready to run production on, but in the next 6 to 12 months, I think definitely that is a production target solution, and probably the right production target solution in the long run for running OpenStack services. Then running on top, there are sort of the two models. There's the container management as a service, and there's the containers as a generic service for your end users. And in both cases, I think it's possible. I think there's still some more work to be done in the container management as a service option for running those environments. And then, of course, there's the interaction at the sort of the infrastructure layers, understanding the network sort of pros and cons of the different network technologies and how they might actually enable both container and virtual machine, and actually eventually also bare metal services all in one sort of mega domain, potentially OpenStack providing that interface, or some other third-party tools maybe starting to provide that interface. The network, the storage, and well, really those two I think are principally the ones that still have some work to be done, I think, to really tie well into the overall flexibility of the infrastructure services that exist today within OpenStack.